Hello and welcome. My name is Stephen Walker and my presentation today is on the temporal magmatic evolution of the Mull lava succession, Palaeogene Igneous Province, Western Scotland, with the contributions from my supervisor, Dr. Joaquin Cortez, and partially funded by the VMSG's Henry Emilius Fieldwork Grant. The aim of this research is twofold. Firstly, to create a more detailed lithostratigraphy of the Mull lava succession using field observations and petrography, and secondly, to investigate the geochemical and textural changes to establish a temporal magmatic evolution. The former aim is what I'll be focusing on today. The Mull lava succession, Western Scotland, is part of the remnants of the early Palaeogene North Atlantic Igneous Province. This stratigraphically well-constrained sequence consists of basaltic lava flows progressively becoming more evolved, with the youngest lavas regressing to more basic compositions. The lavas were intruded by three igneous centres, forming the Mull Central Complex. The green circles on the geological map show the sample locations within this study. Its stratigraphy has been studied since Bailey et al. In 1924, with detailed chemostratigraphy by Kerr in 1993. The sequence begins with the Staffa lava formation, which are the oldest at 60 million years, overlaid by the Mull Plateau Group lavas, and then the Mull Central lavas stratigraphically above, with a duration of approximately 2 million years. However, this temporal evolution of the stratigraphy has not been considered in detail in previous geochemical studies. Here we attempt to identify clear lithostratigraphy based upon the mineralogy of the rocks using field observations and petrography, to interpret the magmatic evolution of the sequence through time. Field observations showed a clear difference in mineralogy and rock texture between basic and evolved flows. Samples were collected over the extent of the island to gain a clear stratigraphic transition between the basic and evolved flow types. The main field observation prevalent throughout the stratigraphy was the continual transition from basaltic into more evolved intermediate and trachytic flows, with distinct mineralogical changes. The basic basaltic flows are mainly porphyritic, with some aphanitic flows. There were visible phenocrysts of olivine, plagioclase and clinopyroxene. This is important as pyroxene phenocrysts in hand specimens have been reported as absent in the Hebridean lavas, so this is really interesting. Minor amounts of iron titanium oxides were found, for example rutile. Several flows were vesicular, with zeolite infills of alteration minerals, and the landscape had noticeable trap topography, which helped to trace flows up the stratigraphy. The petrography revealed some initial findings of embayed texture of olivine, as well as ophitic texture in some of the lavas. I've just started looking at these lavas in thin section, so there's some promising leads ahead. For the basaltic flows, in the northwest area, this interesting outcrop shows one lava intruding another lava. This was originally noted by Bailey et al. In 1924, calling them auto-intrusions. However, this particular outcrop was not fully explained and is not mentioned again in any of the later literature. There are two possible hypotheses for how this formed. The two lavas were semi-solid, and either the weight of the upper flow pushed down, causing the lower flow to squeeze through, or the lower flow, being rich in volatiles, ruptured, bursting through the upper flow. The second hypothesis has more rationale, as the intruding flow, highlighted in yellow, has large vesicles up to a metre in size, seen in the outcrop and fallen blocks. After speaking to Stephen Self, a similar outcrop was documented from the Columbian River basalt group. Self et al. In 1997 interpreted this as a lobe growing by inflation, and the last batch of lava came into the core and caused a breakup through the brittle crust, forming a small surface breakout lobe. Later, another lava formed over the top. This is really interesting and will be investigated in depth further. The more evolved flows can be categorized as either aphanitic with platy weathering or porphyritic. There were visible phenocrysts of feldspar and pyroxene, with possible hornblende and or biotite. In several of the flows in the field, trachytic texture was visible. In thin section, plagioclase anticrysts in several lavas exhibit sieve texture and regrowth, as well as trachytic texture, ophitic texture, and some intergranular flows have also been observed. At the top of Ben More, alkali basalts are reported in the literature corresponding to the core Gorm magma type, and interbedded further down with some evolved trachytic lavas at approximately 600 metres. Here we can see more evolved flows succeeded by basaltic flows. A previously undiscovered outcrop in the area close to the summit of Ben More is suspected to be more evolved, based on field observations, interbedded between basic basaltic flows. The outcrop has slight trachytic texture with small tabular plagioclase and minor mafic minerals visible in a fine ground mass. Now raises the question, what is it? By using thin sections, we can see that both flows are basaltic, with the suspected more evolved flow containing olivine, confirming the literature. However, the flow above appears to have a much finer ground mass, and only olivine in the ground mass rather than phenocrysts. This change in grain size and reduction of olivine will be investigated further through textural analysis. The preliminary field results suggest that fractional crystallization, geochemically modelled by Kerr in 1993, was the main magmatic process governing the succession's development, but with a higher magma mixing contribution than previously thought. This suggests possible magma recharge events bringing more basaltic magma into the system, with fractional crystallization evolving the magma and then magma mixing regressing it back. A higher magma mixing contribution is inferred by the presence of dissolution and regrowth of plagioclase in several lavas and the continual transition from basic to more evolved flows throughout the stratigraphy. Thank you for listening. I'll be happy to answer any questions. Thank you.